Okay, so what we're going to do now is we're going to talk about the average rate of change of a function, which is a very, very important concept of calculus, and you'll use it quite a bit. In fact, a lot of the main ideas for at least first semester of calculus are put the idea of the average rate of change of a function to use. So let's start off by defining the average rate of change. And you've pretty much probably even seen this. So the average rate of change of a function is the amount a function increases or decreases on average from one point of the graph to the next. So in other words, what we want to know is, hey, I'm going to give you 2 points of this function, and we want to know on average, is it increasing or decreasing, and by how much, right? So I'll also show you a picture that will show what's happening here. So it is important to note that although a function may have a positive, or it could even be negative, right? It doesn't matter. So this is kind of like either way. So a positive or negative average rate of change this does not imply that the graph is always increasing. Or decreasing. Between those 2 points. Okay, so I know there's a lot of words here, but I'm just trying to describe the average rate of change to you in words before we actually give you the mathematical explanation or the algebraic explanation. So what I'm saying is, look, if you take 2 points on a graph and you find its average rate of change, and you see that on average the function is increasing, see, the key word is that the average on function is increasing. It doesn't mean that the function in between those 2 points is always increasing. All that means, so it just means that it's increasing more than it is decreasing. So basically what we're saying is it just simply means that the function increases or decreases, right? It depends on the perspective. So when I put this in parentheses, I'm just saying they could be interchangeable, right? So increases more than it decreases or increases, depending on what we're looking at. So visually, here's what I mean. So if we have, think of it this way, we can draw a picture. So if I'm drawing a picture, let's say that this is my function, and I say, hey guys, I want you to find, and don't worry about how yet, I want you to find the average rate of change from this x value to that x value. And when you find the average rate of change, you're basically finding pretty much the slope of this line, right? Because you're saying on average, how much does it change by, right? And so this is, for instance, f of a, and that's the y value f of b. But what is it that you're noticing here? This is changing by what? This is changing, it's increasing, right? So from this point to this point, on average, the function is increasing. But notice how from a to b, the function isn't always increasing. In fact, from here to here, it's decreasing, and then it starts increasing. So how come on average, it's increasing? It's because it increases more than it decreases. So that's kind of what I'm saying here. So we would say, look, notice how f of x increases on average from a to b, but has places on the graph between a and b where it decreases. Okay, so that's kind of the point we're making here, and that's where the word average comes from, right? Because on average it's increasing or decreasing. So if we now define the average rate of change, and I'll leave this picture here so we see exactly how the average rate of change is literally between these points is literally the line of that secant line, okay? Let's define the average rate of change. And then we'll do some examples. So we would say that the average rate of change of the function y equals to f of x between x equals to a and x equals to b is defined as the following. Average rate of change equals change in y over change in x, which if you think about it, that's just literally my rise over run. And we learned last year, and I'm sure even before then, how do we find that? That's just f of b minus f of a over b minus a. And that's your formula. This is what you should box. Now, if you look at this y, that's change in y over change in x. Let's go back to this picture. See, from this point to this point, what's my change in y? It's that distance, which how would you find that length? Isn't that literally just the upper y value minus the lower y value? So if it would be f of b minus f of a. And then what would be my run from a to b? It would be this distance, which would be b minus a. So it would be rise over run. Okay. So with that said, we can say, look, the average rate of change, another way of putting it, which this is, like I said, this is the slope of the secant. So this is like the visual way of describing it. So the average rate of change is the slope of the secant line from a comma f of a to b comma f of b. So that's literally it. So I know that I kind of went into greater detail and I showed you visually what's going on, But mainly this is the formula we're using, but it's not interesting if you're just using a formula and you don't really understand where it comes from and visually how things work the way they do. So let's look at our couple of examples and then we'll pretty much wrap up this section. So the first one is find the average rate of change of f of x equals to x squared plus 7 from x equals 2 to x equals 7. Okay, so let's do this. What is the average rate of change going to be? It's going to be f of b minus f of a over b minus a, where in this case b is where you end, a is where you start, so a is 2, b is 7 in this. So what would f of, so in other words we're saying f of 7 minus f of 2 over 7 minus 2. So what's f of 7? Well, if I basically, that'll be 7 squared plus 7 minus, and I'm putting parentheses because this minus belongs to the whole thing, so it'll be 2 squared plus 7 all over 7 minus 2 is 5, which what's 7 squared is 49 plus 7 is 56 minus 2 times 2 is 4 plus 7, 11 over 5. 56 minus 11 is 45 over 5, which is 9. So what is this saying? From x equals 2 to 7, on average, the graph, the function increases by 9 units. So what they're saying is every time you move 1 unit to the right, your function on average increases by 9. Right now, remember, this is averaging it out. It's not telling you that it's a fact, because there could be places where it's decreasing, but obviously we're just averaging it out. Okay, so here's another one. Now we're generalizing this, so find the average rate of change of f of x equals to x squared plus 7 from x equals y to x equals y plus d. So for this one, now we're just generalizing it, right? Now it doesn't matter, we're doing the same thing here. And the good news is, see, this generalization would pretty much help us come up with a formula that works for any case. So once again, this is f of b minus f of a over b minus a, which in this case b is y plus d and a is y, so this would be f of y plus d minus f of y over y plus d minus y. So what would happen here? Y plus d, if I replace that in for f, I get y plus d squared plus 7 minus y squared plus 7 all over y plus d minus y, which is just d. Okay, so then if I simplify this, what's y plus d times y plus d? We have to FOIL it out. That becomes y squared plus 2yd plus d squared plus 7, and I'm going to distribute this negative, which is minus y squared minus 7 all over d, which becomes, now I could simplify a little bit. The y squareds cancel out, the 7s cancel out, and what do I have? 2yd plus d squared over d, and look at how nice this is. I could simplify a little further, because the numerator I could factor out a d, which leaves me with 2y plus d all over d. The d's cancel out, and what I'm left with 2y plus d. Okay, so b was more a complicated version of a, but you know, same steps, right? We're doing the same thing. So let's move on to example 2. An object is dropped from a top of a cliff. The distance it has fallen in feet after t seconds is d of t equals to 16t squared minus 4t. Okay, so find the average speed between let me move this up, 1 second and 3 seconds, and then for part B, t equals a and t equals a plus h. So you might want to pause the video and do this on your own. But look, how do we find speed? Isn't speed defined as distance over time? So if you think about it, if I want to find the average speed, this formula describes the distance and we have the time. So if they're saying average speed from 1 second to 3 seconds, what would that be? It would be d of 3 minus d of 1 over 3 minus 1. Notice how this is still the same formula, except my function is just d instead of f. So how do I find this out? I need to plug in 3 into that. So I'm just going to use a calculator real quickly to do this. Not that we need it. It'll just be quicker. So this becomes d of 3 is 132 minus d of 1 is 12 over 2. And then 132 minus 12, that's 120 over 2, which then becomes 60. So what is this saying? On average, its speed is 60 meters per second. Okay. Now this one is more like the part B of example 1 where we're generalizing it. So if we generalize it, what are we doing? The same thing. D of a plus h minus d of a all over a plus h minus a. So once again, I'm using the average rate of change formula, which then what's d of a plus h going to be? 16 times a plus h squared minus 4 times a plus h minus parentheses, I'm running out of space here, I'll put it down here, 16t squared minus 4t, so this should be up there, all over a plus h minus a, which is just h. So I'm going to go to a new page just so I have space to work on this. So then if I square the 6 times a or 16 times a plus h squared, what do I get? I get 16 times, I'm only squaring the a plus h for now, so a squared plus 2ah plus h squared, and then I'm going to distribute the 4 minus 4a minus 4h minus 6t squared plus 4t all over h. So I kind of just simplified this, right? I multiplied that out. I just didn't, the only thing I didn't do is distribute to 16. So let's distribute to 16 as well. So that will be 16a squared plus 32ah plus 16h squared minus 4a minus 4h minus 6t squared plus 4t all over h. And by the way, this h should cancel out. So let's see what's happening here. Ooh, I made a mistake here, by the way. This t should be an a, right? Those should be a's, because if you look at this, sorry, let's go back to this. This should be d of a. So that t shouldn't be t squared, it should be a. Okay, so that was a typo on my end. But look at what happens now. The 16a squareds cancel out, and then the 4a's cancel out, and what am I left with? 32ah plus 16h squared minus 4h all over h. And now I could factor out an h, which gives me 32a plus 16h minus 4. These h's cancel out, and I get 32a plus 16h minus 4. Okay, and to wrap up the notes, I just want to start off or finish it off with a question. And my question to you is, what is the average rate of change of a linear function? And when I say linear function, I mean visually speaking, what is it? We're talking about a line. So what would you think, right? So take a minute, think about it. In fact, the average rate of change of a linear function is what? So let's write it out. The average rate of change of any line is the same as its slope. Right? Hopefully you see that. Now if you don't, I could show it to you. I'll show it to you in two ways. One is visually. So look, think about it this way. Pretend that's my line, f of x, and I pick any 2 points and I say, hey, find the average rate of change from this point to this point. What would you be doing? Finding the slope of that line, which isn't the slope of that line, same thing as the slope of the original line. Now, algebraically, how do we show it? We would say, for example, let y equal to mx plus b represent any line, right? Because we're saying it doesn't matter what the line is, okay? With slope m. So then we would say, well, then let's pick any 2 points. Then its average rate of change from x equals a to x equals b is, and now let's use the formula, right? Because what is it that we have? That's our f of x, right? This is our f of x. So let's use the formula. It'll be what? F of b minus f of a over b minus a. And by the way, what should we get? We expect to get m, because we're claiming that it's the same as the slope of its line, right? So let's validate this. What's f of b going to be? If I plug in b for x here, what do I get? I get mb plus b minus f of a, which f of a would be what? ma plus b all over b minus a. So now, if we simplify, distribute the negative, I get mb plus b minus ma minus b all over b minus a. So look at what happens here. The b's cancel out, and I get mb minus ma over b minus a. Now we could factor out an m, and look at how nice that is. The b minus a's cancel out, and I get m, like we mentioned. So and hopefully, like, visually it makes sense, and algebraically it should also work out and make sense. So that's basically it as far as this section goes. So if you have any questions, don't hesitate to reach out to me, but the main idea here was finding the average rate of change of any function. Okay, so once again, don't hesitate to reach out if you have any questions regarding anything from the notes.